Good morning, everyone. My name is May, one of the perfusionists at MGH. The objective of this presentation is to showcase some of the new features of the new ECMO systems that are available in today's market. So let's go over six of the most popular systems here. The basics of all of these systems are more or less the same. All of these systems have a pump to pump blood forward, an oxygenator to oxygenate the blood, and a whole lot of safety mechanisms. Most of them are capable of pumping about 7 liters per minute, which is more or less sufficient for an average adult. Some of the other common features are they all have polymethylpentene microporous or hollow fiber oxygenators. Most of them have a special coating on them. Some of those are heparin and some of those are non-heparin. A membrane surface area anywhere between 1.6 and 1.8 meters square. The normal oxygen delivery to consumption ratio is 5 to 1. A normal delivery is about 1000 mils per minute at rest. Normal oxygen consumption is about 200 to 250 mils per minute at rest. The goal for ECLS is to deliver a DO2 to VO2 ratio greater than or equal to 3 to 1, and all of these systems can achieve that. Medtronic Nautilus is the first system that we're going to look at. This is a smart ECMO module, and it's the first oxygenator featuring integrated monitoring. Here are some of the key design features. It has a circular shape which eliminates corners, which are areas known for clotting. It has a guided inlet which reduces velocity changes at inlet where low flow and stasis may occur. It has filling veins which aid in even filling and even distribution across the membrane. It has an interactive touch screen where you can see the pressure in, pressure out, oxygen saturation in, oxygen saturation out, temperature out. You can set the alarm limits and you can also get visual and audio alert notifications for all of these parameters. The circuit is quite simple for patient transport and ambulation. There are fewer connections, which minimizes number of areas prone to blood clot formation and air entrainment. Another newer, upcoming, bigger player in the perfusion and ECLS space is Spectrum Medical Quantum Perfusion System. Their goal is to combine future technologies with proven quantum performance to maximize patient safety and simplify patient care. Let's look at some of the key features. So the first thing that you see is a Quantum Workstation Elite, and it's a 12-inch workstation that integrates two channels of flow measurements, four channels of pressure and temperature measurement, and non-invasive measurement of oxygen saturations. It also provides connectivity to other quantum modules like the Quantum Ventilation Light and the Quantum Smart Occluder. The Quantum Ventilation Light is essentially a gas blender which provides the user with an atmospheric or hypobaric patient ventilation capability. The max gas flow rate is about 20 liters per minute. It also has an auto regulation feature where it can adjust the gas mixture automatically to maintain a specific PO2. The centrifugal pump has a single sapphire bearing and a technology that ensures levitation at low RPMs, leading to significantly reduced heat generation and hemolysis. A stainless steel venous heat exchanger is integrated with the centrifugal pump. The oxygenator is a dual chamber oxygenator and is capable of hypobaric ventilation. All the fiber layers within the fiber bundle are separated by 10 microns, which means the patient blood is evenly distributed across all fibers and hence ensures maximum gas transfer. Let's take a moment to talk about hypobaric ventilation. When all the gases combined equal less than 1 atmosphere, it is called hypobaric. The quantum dual chamber oxygenator creates a hypobaric condition by only using oxygen and controlling patient PO2 through a VQ mismatch. So, why is this important? It helps minimize gaseous microemboli by denitrogenizing the blood phase. They create this hypobaric condition not by using vacuum but by creating a VA shunt. That's why if you look at the oxygenator, they have two chambers and two gas inlets. One is supplied with 100% oxygen, and the other one is completely plugged. When blood mixes, it creates a hypobaric condition, and because it's 100% oxygen, it helps to push out all the nitrogen into dissolving into the blood phase. Again, this has to be a clinical decision to see if the benefits of hypobaric ventilation outweighs creating the VA shunt and hence reducing oxygen delivery to the patient. So when I say VA shunt, there's blood that is oxygenated with 100% oxygen, there's blood that's completely not ventilated, and there's a mix that's created. One of the biggest advantages of the Quantum Workstation is it has an integrated third party device connectivity solution that enables the central display and transfer of real time clinical information. This could be a big game changer for our ECMO team, especially when they're managing multiple ECMOs at the same time. Let's move on to the next one. It's the Abiomed Breathe Oxy 1 system. Their biggest key feature is mobility. It has a built-in oxygen concentrator, and it hence eliminates the need for an oxygen tank during transports. They have an integrated pump and oxygenator, and they call it their pump lung unit. The oxygenator, a polycarbonate exterior housing that encloses a PMP hollow fiber membrane. They also have um, they also say that the integration of pump and oxygenator helps with uniform blood flow to minimize stagnation and thrombosis. They have two sweep gas delivery modes, an external mode using a blender and an internal mode that uses oxygen concentrator that can deliver sweep up to 3 liters per minute. The oxygen concentrator compresses room air into a sieve that separates nitrogen from air to produce high concentrations of oxygen. The system also has a touchscreen display that helps monitor blood flow, RPMs, battery status, and oxygen source. The next system needs no introduction, and it's our own CardioHelp. Super compact, highly portable, reliable system, and we have plenty of experience with this system. I'm not going to go into the details as we all are quite familiar with this system. We can discuss if we have any questions about the CardioHelp. We're also quite familiar with the next pump, which is the RotoFlow pump, but I know we all dislike the RotoFlow console mainly because of its usability. It definitely has one of the more complicated menu systems, and in an emergency, it's very difficult to get into the right screen. McKay came up with a RotoFlow 2 ECLS system to address this issue. The new system features new design of the RotoFlow system, new holder design, improved and simplified user interface, redesigned RotoFlow 2 drive, new battery management, new features and connectivity. The weight of the system is only about 11 kilos, which makes it quite easy for transports. They also have a hot swappable drive, which means you can change the drive during operation. The final system that we're going to talk about today is the Leva Nova, and they call it ECLS in a box. The system comprises of a LifeSpark pump with a tandem lung, which is their oxygenator. The tandem lung consists of a hollow fiber membrane with blood inflow and outflow port and a gas inlet and outlet port. That's it, there's no heat exchanger. Blood enters into the center of the fiber bundle, where it is distributed radially and uniformly across the fiber bundle by a conical diffuser. So the chart that you're seeing is actually the HQ chart, and it shows the flow characteristics of the pump over a range of conditions. The flow rate represents the relationship between RPM and pressure differential between the inflow and the outflow of the pump. An estimated flow can be determined by using this chart. So if you look at the chart, the x-axis is the flow rate, the y-axis is the pressure drop, which is H, and then the different RPMs are mentioned on the graph. So for a flow of 6 liters at 3500 RPMs, your pressure differential would be around 120. The pressure flow curves are presented here were generated using 42% glycerol, 58% saline solution. The viscosity is pretty close to blood. But keep in mind, this HQ graph is without an oxygenator. So the introduction of an oxygenator into the extracorporeal circuit will result in reduction of the maximum achievable flow. In summary, All of these devices are able to satisfy patient clinical needs in terms of providing circulatory support and oxygenation. When it comes to reliability and safety, we have so far had a good experience with CardioHelp. I reached out to a couple of centers that are using the Nautilus oxygenator, and they're extremely happy with its performance. However, one site used Spectrum pumps with Nautilus oxygenator, and they noticed that the Nautilus clotted more than the Quadrox oxygenator with their standard anticoagulation protocol. Spectrum Quantum Perfusion System also gained high points with reliability and safety. There's definitely a learning curve to the Spectrum system, but the software and data management capabilities are phenomenal. For the most part, all of these systems are able to transfer their data into EMR. University of Maryland used the Abiomed Breathe system mainly because it was pioneered by one of their surgeons, but they seemed to be less impressed and abandoned it completely in the last couple of months. They noticed that the positives were it was super user friendly, very easy to prime, and it was very mobile. Just like the Levanova Spark, the Breathe also did not have a heat exchanger, and the two large bore stopcocks on the oxygenator have popped off multiple times that led them to stop using the Breathe system altogether. They also noticed that the console wheels are small and can get stuck in elevator spaces. So, from my little survey in one of the perfusion groups, most people used Centromag with Quadrox oxygenators, and the second place was bagged by CardioHelp. Again, these are new technologies and new pumps, and with time, we will be able to get more information. I'm going to open it up for discussion now, and let's talk about how we can pursue some of these technologies. Thank you.